Okay, so what we're going to start out with here is classifying expressions, specifically polynomials. So you've probably seen polynomials and you just don't realize it. Remember, a polynomial is any combination of numbers, variables, exponents, okay, anything that has addition and subtraction in it. So polynomial is a very general term. We can classify them more specifically with these special ones when we're talking about different terms. But before we talk about how we classify them, let's talk about what a term is. Okay, a term is going to be separated by addition and subtraction signs. So I'm just going to abbreviate here. Separated by addition and or subtraction. Okay, so let me give you this example here. So if I just have one term, that means I have nothing added or subtracted to it. So it could be like 3x. Okay, that's one term. It could be something like just a number, 4. It could be something just a letter, a variable, like y. Okay, it could also be something like multiple variables. So it could be like x squared y to the third z. Okay, that's still a one term because nothing is being added to it. And what we call that is a monomial. Monomial. Okay? So that's one term. Two term, you probably heard of this. Okay, this is called a binomial. That means you have two terms, so two things added or subtracted. So it could be like 3x minus 4y. It could be x squared plus 4. Okay, you've probably seen that somewhere before. So those are binomials, two things being added or subtracted together. Okay, notice that you can't simplify anything, so like 3x minus 4y, I can't put that together. A lot of the time students will say like, oh, 3x minus 6x, that's a binomial. Yes, it's two terms right now, but technically you can simplify that to be negative 3x, and now that's a monomial. Okay, make sure that if you are asked to write this, make sure you can't simplify them at all. Okay, and it still stays within the context of the problem. Okay, three terms is what we call a trinomial. And a trinomial is going to be three terms added or subtracted together. So something like x squared minus 2x plus 24. Okay, something like that. It doesn't have to be the same variable. It could be all different variables. Just got to be three added or subtracted together. And when you have four, this is called a polynomial. Okay, just write 4 or more. Okay, so that's a polynomial. Anything 4 or more, 4, 5, 6, 7, and so on, it's going to be a poly. Poly means many. Okay. Okay, now let's talk about classification by degrees. Okay. A degree is the highest amount of exponents in one term. So if I have a 0 degree, that means I have no exponents, which means I have no variables. So I can only have numbers. 4, 3, -1, something like that. Okay, this is what we call a constant. There is no variable. There are no variables. There's no change. There's just numbers. So this is called a constant. We're going to define degree here in a second once we kind of get into it. If you have a first degree, this is something like 3x minus 1 or 1/2 x plus 2. Okay, you probably remember seeing lines, equations of lines like that, and you were asked to graph those and find the slope and all that stuff. Well, if you remember, those are called linear functions. That's because you have a degree of 1. Okay, if you notice you have the x here, the variable, well, the exponent on this x is a 1, making the degree of this whole thing a 1. Okay, that term has a degree of 1. This last term here has a degree of 0 because it has no variables. So we say the degree of this whole thing is 1 because we're going to take the highest amount. Okay, if that was confusing, just hang with me. I think it helps when we get the higher numbers. So with 2, this is called a quadratic. This is something like x squared minus 4. or x squared minus 2x minus 24. Okay? Both of those are quadratic. Obviously, one is a binomial because it has 2 terms, and one is a trinomial because it has 3 terms. But both are quadratic, and here's why. If you take x squared minus 4 and x squared minus 2x minus 24, you're going to go term by term here and figure out what the degree is. So in this first term, in x squared and then 4, the degree in x squared, again it's the exponent because it's 2, okay, and then the degree in 4 is 0. The highest degree is 2, so we say that this one has a degree of 2. With this one over here, the first term has a degree of 2, the second term has a degree of 1 because the exponent on the x is 1, and the degree on 24 is 0, it has no exponent. So we say also that this one has a degree of 2 because 2 is the highest. Okay, so both of those are quadratic. It doesn't always have to have 2 terms, it could have 3 terms, but as long as the degree of the whole thing is 2, it makes it a quadratic. Okay, moving on to 3, this is called a cubic. Okay, that's something like x cubed minus x squared. Okay, it could be as long as this. X squared or x cubed minus x squared minus x plus 1. As long as the highest degree in each term is 3, that's a cubic. Right. Same thing in 4. Cubic is called, or a fourth degree is called a quartic. Q-U-A-R-T-I-C. So x to the 4th minus 1. Now if we want to get really crazy, if you really understand what degrees are, you could do that. And even this, I'm going to write this down here in blue. Once you finish writing that, check this out. That's still a quartic function. Why? Because again, if we go term by term, this first term has a degree of 1. Whoops, I lied. Let's pretend like that x isn't there. Okay, this is still a quartic because this first term here, yz, so I'm going to go ahead and get rid of, nope, that one still works. Anyway, I'm going to take yz here. So y has a degree of 1, so does z to the 3rd. That has a degree of 3. So altogether, this term, because there's no addition or subtraction in between them, we're going to add those exponents together. This one has a degree of 4. This x, this next term, has a degree of 2, and this 3y to the 2nd also has a degree of 2. But because the 4 is the biggest, we say that this has a degree of 4. So it doesn't always have to be one single variable to that exponent. It could be a couple of them, like I did in the example, x squared y squared plus 1. X squared y squared together has a degree of 4. Now, to the 5th is quintic. So this could be like x, what I just did, x, y, z to the 3rd. That has a degree of 5. Or it can just be as simple as x to the 5th. Now, anything larger than 6 and larger is just going to be called by that number. So like the 6th degree, the 7th degree, the 8th degree, and so on. Okay, so x to the 6th, x to the 7th, whatever it is. You're just going to call it by that amount of degree. Okay, so let's practice. We want to classify the number expression by degree and the number of terms. So 2 things that you classify expressions by, the degree and the number of terms. So 2 words, degree always comes first, and then number of terms comes second. So I'm going to do the first one, you're going to do the next 2, and check your work. So in the first one, I'm going to look at each term. This term has a degree of 4, this term has a degree of 2, this one has a degree of 1. So the highest degree is 4. That means I have a quartic. And there are 1, 2, 3 terms, so that means a trinomial. So you'd say this is a quartic trinomial. Okay, you go ahead and do the next 2. So pause it, and then I'll tell you the answers. Seriously, pause it. Okay, so number 2, hopefully you got a chance to try it. And number 2, our degree is going to be 3. Don't forget that little 1 on the y, that still counts for the degree. So degree of 3 makes this a cubic, and there's nothing added or subtracted, so this is a monomial. Even if it has multiple variables, as long as there's no addition or subtraction, it's still a monomial. And then with 3, you got a little exponent on the x of 1, so this makes it a linear. And again, one term, nothing added or subtracted, so it's a monomial.